Hey everybody, welcome back to the Curly Boy Theatre after Heidi's amazing keynote this morning. I'm Lily Ryan and I'll be your MC today in the Curly Boy Theatre. And first up, we have Christopher Neugebauer talking about the Zen of Python. Now, Chris is here with me live, but this talk will be pre-recorded, so Chris will be able to answer all of your questions in the Venules chat on the side of the page while he's speaking, which is part of the advantages of having an online conference. To tell you a bit about Chris, Christopher Neugebauer is an Australian developer, speaker, and serial community conference organizer who presently lives in the United States. He serves as director and vice chair of the Python Software Foundation, and when all this is not currently preventing it, is co-organizer of the acclaimed North Bay Python Conference, a boutique one-track conference run in a live music venue in Petaluma, California. We're very excited to have Chris here today. How are you doing?
Doing very well. Thanks, Lily. I'm excited to share this talk with you.
I'm excited to hear it. Okay, I think, AV, we are ready for the talk.
Hey there. Over the last few years, I've been talking about what makes good Python code, often by talking about how Python approaches ideas from other programming languages. And today I'm here to talk about the Zen of Python, which has been with us since time immemorial. We've been using the Zen of Python to help us figure out how to write good Python code. And because many of us are people who get into arguments on the internet, we use the Zen of Python as fuel for those arguments. I think it's a good year to talk about the Zen of Python and its limitations, and to talk about whether it does what we think it does. And I've been a huge fan of the Zen of Python for many years. This was reinforced for me 10 PyCon Australias ago when Richard Jones gave a fantastic, sadly unrecorded deep dive talk called The Zen of Python. And he showed how the Zen of Python was used in Python and its standard library. Here's the abstract of that talk in its entirety. It really was that good. Anyway, that talk shaped how I think about writing Python code because I saw how to put the Zen of Python into practice. And it taught me ways to recognize whether some code was good Python or bad Python. But in my talk at last year's PyCon Australia, I looked to the Zen of Python to answer a question in a talk I'd written. And for the first time, I was left bereft. I had found a design problem in Python, and the Zen of Python couldn't save me. And that's what I've come here to talk about. Tim Peters' 20 Python Theses. And no, that spelling is how he introduced it. And only 19 of them have been written down. But it's still known as the Zen of Python, or PEP20, or that thing that appears in your terminal when you type import this. And here are those 20 theses. Now, immediately in that very mailing list thread where Tim introduced it, people thought it was fantastic and it described everything that they thought Python was about at the time. It was concise, it was opinionated, it explained in very clear terms how Python thought differently to Perl. And in the 1990s, that was super important. And in the years following, people started to identify languages with a prescriptive design philosophy. A good example of that is Java, which was intended to be familiar to C developers like C++ was, but without all the ways that C++ let you shoot yourself in the foot. Looking at the Zen of Python, especially its first few lines, also made people think that Python had a prescriptive design philosophy. This was in contrast to, say, Perl. Now, for the longest time, I have referred to the Zen of Python. I have referred to it when introducing speakers at conferences. I've used it to answer questions that have been raised in my talks. And I've used it to solve design problems in my code. I've definitely thought of the Zen of Python as evidence that Python has a prescriptive design philosophy. But it isn't. Today, I want to show you why the Zen of Python isn't prescriptive and why it's a terrible way to settle arguments about the right way to do things in Python. Today, we're going to look at 2 design decisions made since the Zen of Python that was written that appear to have ignored the Zen of Python. We're going to look at some code that the Zen of Python thinks is reasonable, but isn't. And we're going to look at whether the Zen of Python ruins our understanding of why Python is the way that it is. So, I mentioned earlier that I got confused by the Zen of Python last year. The Python feature that confused me was the decorator. The decorator exists because sometimes in Python you need to modify the behavior of a function. People have been modifying the behavior of functions since well before decorators existed. And one popular way to do this was through a thing called the decorate pattern. The decorate pattern looked like this. First up, you define a function, and then you pass that function into another function, assigning it back to the original name. Now this approach is fine for short bits of code, but things can fall apart really quickly. If you need to decorate the same function twice, things get a bit repetitive, and you have to decorate your function from the inside out. So the last decorator you apply is the outermost behavior at call time. And it suffers from really poor concept grouping. The decorator can substantially change the behavior of a function, but here it appears after the method body. And if your method's long, it might not even appear on the same window. This can make for unreadable code, and as we know from the Zen of Python, readability counts. And so PEP 318 gave us some syntax for the decorate pattern. We have decorators now. We know that def means that we're defining a function or a method, and so seeing a decorator means that function has modified behavior. In this case, we know that the new behavior is, firstly, that it's synchronized, and secondly, that it's a class method. Now, this won't be surprising if you saw my talk last year, but that understanding of decorators isn't exactly true. If you put a decorator before a function definition, it doesn't change the behavior of the function, it actually changes the definition of a function. Let me show you what I mean. Say you define a function called squares, which multiplies a number by itself. You can call that function and you get a value and everything is great. Now here's a decorator. It's called apply. When you decorate a function with it, you provide a transform lambda, which accepts a function as a parameter. And when you decorate the function with apply, it calls the transform function with the decorated function as its parameter. And instead of returning a callable, it returns the result of that transform function. So if we take our squares function and decorate it with apply, and let's pass in map as our transform function. Now, after we define our function, squares isn't a callable. It's a list, because that's what our transformer returns. So we created a function using def to be called once at definition time and then discarded, just because that's what the decorator does. We define a callable, but we end up with a list in its place. And the fact that the thing that we define is no longer necessarily callable isn't obvious from syntax. But it's there pretty plainly in the old decorate syntax. There's nothing that says that this thing has to return a function. And that brings us to the Zen of Python, which says that explicit is better than implicit. In Python, def name explicitly means that name is a callable. That's a contract with you, the developer. And apply lets you break that contract. So decorators let you break the contract of def quite easily. Could they have done any better? Well, what if we made it so the things that decorators put in their place are callables? Well, that would solve our immediate ambiguity. But since decorators were invented, this thing called a property descriptor came along, and I think property descriptors are very Pythonic, and they're implemented using decorators as well. Once you decorate a method with property, you don't call the method you defined by calling it, by putting parens there. You call it by accessing or assigning to the attribute that it's a property defined for. So you're calling code as a side effect of a completely different operation. And you have to know that this property thing does this weird behavior modification. That's hugely implicit, even if it's more readable. So we see that decorators turn function definition into implicit behavior, which depends on what the decorator function does. So if we follow the Zen of Python, then decorators must not be Pythonic. So let's skip ahead 13 years of Python evolution and ahead to 2015, which was a much more interesting time in core Python world, because Python had got popular. And you know that if you run mailing lists for things that are popular, you know that random people from the internet show up. And these random people had never got involved in language design before, but they saw Guido's keynote at PyCon 2015 and they decided to contribute to design discussions that were previously only amongst core developers. Those people came from a generation of Python developers who learned to solve design problems with the Zen of Python, and understood that simple is better than complex. And there's no better demonstration of Python's simplicity than looking at the first program you write in Java. You need to know an awful lot about how to program to write Hello World in Java. You need to know about types, you need to know about classes, you need to know about function definitions, and Python's version is just so much simpler. But this simplicity is limited. Python requires you to test behaviors with unexpected types. Automatically translating code was difficult, which shot us in the foot when we transitioned between Python 2 and Python 3. And tools like IDEs were much more complicated to use as a result. And as the Zen of Python says, well, explicit is better than implicit. And so it was that we used a feature that got added in Python 3 to let you provide argument and return annotations to give you the opportunity to provide argument and return hints. And now you can specify your function's contract with its callers, and these can be automatically tested by a type checker. But in doing so, things become less simple. Providing type hints is an extra piece of complexity that wasn't there previously. And as you add type hints, your code can get crowded and verbose, and that reminds people of Java. But type hinting resolves ambiguity that doesn't need to be there. Basically, type hinting laid bare a contradiction. You had to choose between simplicity or explicitness, ambiguity or ugliness. You would have to choose where to accept your complexity. The Zen of Python couldn't resolve this argument. So we see two cases where the Zen of Python just didn't help matters. And if you think the Zen of Python is there to tell you what Pythonic choices are, well, you're probably asking yourself a question right now. Is Python Pythonic? Well, the answer to that one comes from actually reading the Zen of Python. We saw that decorators are a feature that significantly improve the readability of Python code. But in doing so, they take away a feature of Python with quite explicit behavior and turn it into something implicit. And we saw that adding type hints takes the simple structure and understanding of Python code and makes it more complex. And we saw that not including type hints means that the expected behavior of functions is implicit. These are two cases where the Zen of Python does not guide you towards a good solution. And as Tim said, if the answer to any Python design issue isn't obvious after reading those, you should give up. If you take the Zen of Python at face value, you'd have to say it's failed to guide Python in the right direction. But I hear you say these are special cases. These do important things. And the Zen of Python says something about that as well. It says special cases aren't special enough to break the rules. But almost as an afterthought, it also says that practicality beats purity. So what does it mean for practicality to beat purity? Well, it means that not everything neatly fits into one of those catchy little boxes that the Zen of Python created for you. It means that sometimes you need to make choices. By the Zen of Python, allowing implicit behavior means that decorators aren't Pythonic. But decorators encoded an existing use case. Remember in the before times? When you wanted to decorate a function, you would need to sacrifice readability for functionality. As they were eventually implemented, decorators let you do everything that people were doing beforehand. It meant that every use case where people were decorating functions was covered by the new syntax, and it allowed for innovations like property descriptors. Type hints solved a real use case that real Python developers could not solve with Python. Inferring the types that a function would accept or return was difficult. This limited the tools that you could use with older Python code, and by the Zen of Python, well, if you believe that explicit is implicit, then Python's original approach to typing was not Pythonic. But it did make a practical choice for writing programs quickly. The solution isn't simple. Good type systems are inherently complex. Bad type systems make it really complex to write code. But type hints enable simplicity in tests, in tooling, and in automatic translation. So Python chose a system where you could choose to opt out of static typing completely. There's a rich and useful type system for people who need it, and if you don't, you can opt out completely, which is the very definition of a practical choice. If you prefer static typing, if you prefer dynamic typing, or if you want a mix of both, you can get the programming language you want. So Python design decisions value simplicity, explicitness, and a whole bunch of other things, but it also values practicality. Now, this is a real factor in design decisions, but it acknowledges that not every design problem fits into rules. Or to put it another way, Python doesn't tell you how to do things. But the Zen of Python also talks about being able to do things. It says that there should be one, and preferably only one, obvious way to do it. And this is an approach that's actually served the language pretty well over the years. Basically, it says that you should find a way to do something and then keep iterating until it is obvious that that is the way to do things. But that means that in order for there to be a one obvious way, you need to try out a bunch of other ways first. And quite often, one of the ways that we choose on that path might seem like the one obvious way. I've given talks in the past where multiprocessing and requests were the one obvious way. They in turn replaced threading and URL open. Today, I tell you to use async.io and I tell you to use AIO HTTP. These things became the one obvious way because someone decided that the old way wasn't obvious enough and they experimented. Finding the obvious way involves experimentation and a certain acceptance that there needs to be a way to do it, and you have to try out various ways to find that way. And generally speaking, Python is a language that gives you the tools to bend things to your will. Things like Django's ORM, they're only possible because Python lets you subvert normal behavior and replace it with something different. So let's take a feature that Python has deliberately long chosen not to implement: the switch statement. Actually, in this case, we're going to look at its more modern variant, pattern matching, because Python really should be keeping up with the times. As an example, let's look at one of those terrible programming interview questions, FizzBuzz. Now, to solve FizzBuzz in Python, you usually need a bunch of if and elif statements to solve it. But this version is tedious to write. You need to make sure you spell the out variable correctly in every single one of those if blocks. And you might say, you can refactor this with a function. And I'd say, yeah, you could. But it doesn't really help. You're still writing return a bunch of times, and you've added an extra line of code, and you've added a level of indirection. What I would prefer is something more like what Kotlin has to offer. You get to pull the variable assignment out of this when block, and you're left with just the conditionals and the block of code to execute when that condition is true. It's simple, it's concise, and I really want something like that in Python. And as we know from the Zen of Python, there should be one way to do it. And I know that the core team has been pursuing pattern matching, but the Zen of Python also says that now is better than never. So what tools do we have right now? Well, if you think about it, these are just blocks of code that gets executed under certain circumstances and return a value. These are the conditions where those blocks get executed, and this is where the value of the executed block of code gets stored. So what we need is just a way to group several blocks of code, a way to define the conditions when those blocks execute, and a way to store the output of whichever block executed. So you might ask yourself, does Python have the tools that we need to implement this? Well, first up we have @case. It's just a boring standard function decorator. It even just returns the original function. There's not really anything magic going on here. There is magic in this switch decorator though. It chews up the contents of a class, runs all of the functions you gave to case decorators, and executes the method with the first matcher that passes. Together, @switch and @case are written in 37 really sparse lines of Python code. It doesn't use anything creepy like inspect or bytecode decompilation. But together, they can turn a class with some methods into a functioning pattern matching implementation. And the implementation of FizzBuzz isn't awful. It suffers from a lot of repetition. If you read the code, it's not obvious why this is a class with methods, but these are the tools that Python has given us. On balance, I think it's less readable than the function version, but I would much rather inline this than the multi-if version with variable assignments. This might not be the final obvious way to do it, but it solves a problem for me now, and I can see situations where this could be the obvious way. And as the Zen of Python says, well, now is better than never. Which is to say, if you need something, maybe you should implement it with the tools that you have. But it also provides a word of caution. It says that never is often better than right now. And so if we follow the Zen of Python's guidance, we find ourselves in a situation where the only way to do things involves doing something that isn't obvious. So we shouldn't do it because it's bad Python. But we've seen that Python grows because people try things out, decide that the best current approach doesn't work, and improve upon it. So what is practicality here? Is it using the tools that we have to structure code in the way that we want? Or is it making use of what Python gives us and accepting that there may just never be a good way to do something, even if it seems obvious at the time? So I've spent the last 10 years thinking about Python in a certain way. And last year, I found myself confused by the advice of the rules that we use to write good Python code. I've been thinking about this fundamental assumption about how Python wants us to do things, this prescriptive design philosophy that I thought the Zen of Python gives us. Or, put another way, can we follow a set of rules and always end up with good Python code? Well, over the course of today's talk, we saw that even in fundamental design cases, the Zen of Python, or PEP 20, gives contradictory advice. Accepting one of these 20 theses often means giving no weight to another one of those same 20 theses. So it's not a matter of deciding whether following the rules will give us good Python code. It's a matter of whether we can even follow the rules at all. PEP 20 doesn't help us be prescriptive, but there's a PEP that's all about being prescriptive. And that's PEP 8. It's a style guide. It tells you exactly what you should do. It's the very definition of a prescriptive PEP. It should be exactly what we want. But if you actually read PEP 8 as far as the first heading, you're confronted with this. A foolish consistency is the hobgoblin of little minds. What does that mean? Well, it doesn't mean that it's bad to be consistent. In fact, it means quite the opposite. It means that you can be consistent, but you shouldn't be mindlessly consistent. It means you need to think and to consider whether it makes sense to be consistent. So the most prescriptive of all the PEPs says that you shouldn't be foolishly consistent. Python is not prescriptive, but it's easy to think that it is. But it's not that. Python is opinionated. It's a language that has a strong opinion of how things should be done, and the Zen of Python is just a list of one man's opinions. Mind you, they're generally good opinions, which you can use as guidelines to design better software. But they're just that, opinions. And opinions, no matter how much you agree with them, aren't actually rules. No matter how much your favorite part of the Zen of Python guides your development, it doesn't mean that it's the only factor in making good code. Remember that different people have different use cases, and Python grows because we support those use cases. Keeping a narrow view on the use cases that you value doesn't keep the language simple. It keeps it simple for you. When problems come up that Python can't solve, keep an open mind that people are actually having these problems and that we can make Python simple for them as well. That should be our guiding principle. And while Python is an opinionated language, it has a strong design aesthetic. It's that way because the people who've designed Python made choices about how to improve the language. If you want to write good code, sometimes that means valuing some design options over others. Sometimes both opinions you must choose between are from the Zen of Python. So how do you choose? Choose practicality over purity. Right. Thank you. If you've got questions, come join me in the hallway track after this talk. I think there's a link somewhere visible to you now. If you're watching this on delay, please ping me by email or Twitter. There are notes for this talk at chrisjrn.com. And finally, thanks to everyone at PyCon Online for making this happen. I'm looking forward to not giving another talk under these circumstances. See you next year. Bye.
Thank you so much, Chris. That was an excellent talk. And we were all really excited to have you here in the chat, able to talk to us while you were talking.
Yeah, it was a very meta experience.
Well, we hope that there aren't very many more under this kind of circumstance, as you said. But for the moment, you're going to be in the video hallway. Is that right?
Yep, ducking into one of the two video hallways, depending on who's whichever one is quietest. So if you've got any questions or want to talk about Python philosophy, you know where to find me. Thanks everyone for coming on. The discussion was great. I really look forward to seeing you all in person real soon now.
And thank you for the talk as well. So right now we're going to have a little bit of a break while we get our next speaker ready. But we hope to see you back here in about 10 minutes.